Well, hello there, Algebraniacs. Welcome to the Johnson Kendall Video Hour.
But it's not an hour.
Nope, today is going to be lickety split. Not an hour for sure. All right, 7.3 Part 1 Logarithmic Functions as Inverses.
What's a logarithm?
Woo, I don't know, but it's a rhythm with logs. We're getting rhythmic here. Okay, logarithm to the base b of a positive number y is. Here we go. If y equals b to the x, then the log of base b of y equals x.
Woo. Okay, so we need to be familiar with these two forms. This is called exponential form. And that kind of makes sense. There's a number to an exponent. And then this is called log form. Or logarithmic form. And I think that kind of makes sense because there's the word log in it.
Yeah, that makes a lot of sense.
So logarithms are going to help us solve for exponents, which we've never, ever done before without doing guessing and checking. So part of your assignment today is just practicing switching between the two forms. So you need to first know what form you have, and if you have something to an exponent, you have exponential form. So what we want to do is convert it to the opposite form. So let's identify each piece of this. This is the y, because it's the number without the exponent. The b is the base, it's the number that is raised to the exponent. And then the x is the exponent.
Yeah.
Okay.
X stands for exponent.
So once you've identified those, then you're just going to rewrite it in log form. So write the word log, and then base, it's got to be a, what's that called? Is that superscript? I never remember.
Yeah,
Is that subscript?
Sub
okay.
is under, like
And
the subway.
Oh yeah, good call.
Super
Is
is
above?
like
Superman.
Superman flies above. Yeah, there we go.
Okay, so log base 5 of 25 equals 2. And what logs do, it's this number to this power equals this.
Okay.
So it's kind of complicated, but today's basic, we're just practicing converting between the two forms.
So exponential and log functions are kind of inverses of each
They
other?
totally are inverses.
Oh, very cool.
So let's do the same thing like this time. We're starting with log form, and then we're going to convert it to exponential form. So again, follow the formula, log base b. So that means that the 2 must be the base. And then the 8 is the y, and this is the x.
Okay.
So we want to write it like this now.
Okay.
So 8 equals 2 to the third, and that's a true statement that you guys know anyway.
True. Yep. Very good.
All right.
Let me try some of these.
All right, we're going to evaluate next.
Okay.
So what does it mean to evaluate a log?
So we just find the value, and to do this, we've set up a little system here for you. The first thing is we want to set it equal to x. So we're going to do that. Now it's in our log form. Whoops,
Other way.
That we showed you right here. So we've got these 3 pieces to it that we want to use.
So log base b of y equals x.
Right, so this is b, this is y, and this is still x.
Okay.
So now we're going to switch it back to our other one.
Up higher. There you go.
And right here, we're going to switch it to this one and solve it that way, because we know exponents, we don't know logs very well. So we take base b, which is our 8, set it equal to the, or raise it to the exponent and set it equal to the y part.
Wait a second, I noticed that you put the b and x on this side and the y on that side. Is that okay?
Yeah.
What if I went this way? Is that the same thing?
Yeah, remember
Totally.
Commutative logs, those still form.
Okay, good. Just checking.
All right, so we just converted it to exponential, and now we have to write each side using a common base. Now this is a part we haven't done before. So, common base, we have to figure out what they have in common. So 8, I'm going to write over here.
It has an exponent.
2 cubed. 16 is 2 to the 4th. So their common base is a 2. So what we want to do is change 8 into 2 cubed and still raise it to that x. And the 16 is a 2 to the 4th.
So it has to be the same number, like the 2 and the 2.
Right.
Okay,
Because
that's the
we're
common
making
base.
them equal, we have to make sure the bases are equal to do the next step. Okay, the next step is set the exponents equal to each other. Now, I've got a power raised to a power.
Power,
So we
Rangers.
multiply, right?
That's 2 to the 3x, yeah.
So 3x and then 4. Those are our exponents. And if 3x equals 4, divide both sides by 3, then our answer is 4/3.
And that makes sense if you go and take this 4/3 answer and plug it in for the x there, like on the calculator, or using your fractional exponents that you've used before, you will get 16, and then you know that it works.
All right.
So in the past, I've noticed kids have a hard time going from this step to this step. So just, if you think about, you have the same base raised to exponents, and there's an equal sign in between.
Right.
You know, so if you have something to a power, well, let me do it this way. If you've got some number to a power and there's an equal sign in between, as long as those numbers are the same,
Then the
powers have to be the same, and that's how we got 3x equals 4.
Aha.
We'll talk more about that later.
Those look like some googly eyeballs.
You know, we draw machines, we draw pictures.
We
Whatever
are
works.
artistic mathematicians.
Do you want to do one more, or you want?
Sure.
Okay.
I'll do one more.
All right.
All right, so I'm going to use the same rules as I did before. I'm going to set it equal to x. Then I'm going to take the 9 to the x power equals 27.
So that's converting it to exponential form.
Right. So now I have to get the same base. I know that they both have a 3 in common. So 9 turns into 3 squared, still raised to the x. 27 is
3 to the third.
cubed. Now 2 times x is 2x.
Okay.
Equals this 3.
So setting the exponents equal.
Right, and then divide by 2. So I get 3 halves. Why can't I make my 3?
You're not pressing hard enough.
Oh, okay.
All right, can I try one?
You try it.
All right. Oh boy.
Oh my, we got fractions. I'm glad I gave you that
I
one.
guess. I didn't know what I was getting into under that box. All right, so set it equal to x. Then the next thing, this was the b, this was the y, there's the x. So we're converting to exponential form. 64 to the x power, because b to the x equals the y, which is 1/32. And we're going to give you a hint when there's fractions. So I don't like fractions, and most of you don't like fractions. So what you can do is rewrite the fraction using an exponent. So 32 to the -1 power is the same as that. So then we can just focus on 64 and 32.
Uh-huh.
So we got to pick some number that I can raise to a power that would get me to 64, that would also get me to 32. I was kind of tempted by 8. I was kind of tempted by 4, but I don't know powers that I could raise either of those two to get 32.
How about 2?
Okay.
2 usually does those.
Yeah, 2 to the, what is that? Is that,
6.
That's the 6th, is 64. And then this time we're going to need parentheses over here too because of that -1. 2 to the 5th is 32.
Uh-huh.
So now we're ready to set our exponents equal to each other. So 6x, and remember you got to multiply there. 6x equals -5, divide by 6, and we get -5/6. And that would make sense for us to have a negative answer because that's really the exponent that we'd have to raise 64
and
to.
32 is on the bottom,
Right.
which gives you a clue that exponent's -2.
Okay, one last little thing we need to talk about here. Common logarithm. So it means it like happens all the time. What does that mean?
Means, yeah, people use it more often than others.
Okay, so common log.
It's because mathematicians are lazy. They come up
No,
with
but
these
sometimes
shortcuts.
it gets confusing.
Yeah, true.
Okay, so you will never see log base 10 written out.
So if there's nothing there,
Yeah, the kids are going to see this.
oh, nothing's there, then it's considered
It's really
base 10.
And you can write it in.
It's kind of like x to the first power is really just x.
Right, exactly the same concept.
All right.
And you can't mock my LOGs because every year kids mock on that too. It looks like a cursive W or something.
I won't mock you.
Okay.
We're
Hey,
just,
we're done.
We're just log off now. All right.
Logging off.
Logging off. Ta-ta for now.